Imagine a sheet of glass, clear, transparent, just like the window in your home. Now imagine someone fires a powerful bullet directly at it. You expect the glass to shatter, explode into thousands of tiny pieces, but instead the bullet stops. The glass cracks, but it doesn't break apart. The people behind it remain safe. How is that possible? How can something that looks like ordinary glass stop a bullet traveling over 3,000 kilometers per hour? Is it made from special glass, or is there something hidden inside? What happens the instant a bullet hits bulletproof glass? Why doesn't the energy pass through, and how many bullets can it stop before it fails? The answer is one of the smartest engineering inventions ever created, a material designed not to be unbreakable but to absorb an unbelievable amount of energy. Today, we are going inside bulletproof glass to discover how it works, why it stops bullets, and the incredible engineering that protects banks, armored vehicles, airports, military bases, and even presidents. This is the engineering behind bulletproof glass. At first, bulletproof glass looks exactly like ordinary glass, clear, smooth, transparent, but inside it's completely different, because bulletproof glass isn't just glass, it's actually several layers pressed together, engineered to work as one. The outer layer is hard, tempered glass designed to resist the first impact. Behind it is a tough, transparent plastic, usually polycarbonate, a material far stronger than ordinary plastic. Then another layer of glass, then another layer of polycarbonate, again and again, depending on the level of protection. When a bullet strikes, the first layer begins to crack. This is completely normal, because the goal isn't to stop the bullet with one layer. The goal is to slow it down. As the bullet breaks the outer glass, it loses part of its energy. Then it reaches a plastic layer. Instead of shattering, the plastic flexes, stretching like a net, absorbing the remaining impact energy. Each layer steals more speed, more force, more energy, until finally the bullet runs out of power and stops. The glass may be cracked, but the bullet never reaches the people behind it. That's the secret. Bulletproof glass doesn't defeat the bullet with strength alone, it defeats it by slowly stealing its energy, layer after layer after layer. Now comes the biggest question: if the outer glass cracks, why doesn't the entire window shatter? The answer lies in the plastic. Ordinary glass is brittle. Once a crack starts, it spreads almost instantly. That's why a small impact can destroy an entire window. But bulletproof glass behaves very differently, because every layer is tightly bonded together using powerful, transparent adhesives. These layers prevent the cracks from spreading. When the bullet breaks the first sheet, the plastic holds everything together. Instead of flying apart, the broken glass remains trapped inside the laminated structure. This prevents dangerous glass fragments from becoming deadly projectiles. At the same time, the plastic layer begins to stretch, not much, only a little, but that's enough to absorb huge amount of energy. The bullet starts to flatten. Its speed drops rapidly. Its shape changes. Every layer takes away a little more energy, until finally the bullet can no longer push forward. It stops, not because the glass is stronger than the bullet, but because the bullet has already spent almost all of its energy. That's the genius of the design. Bulletproof glass doesn't fight the bullet all at once, it defeats it little by little, one layer at a time. At this point, you might be thinking, if bulletproof glass can stop one bullet, can it stop every bullet? The answer is no, because not all bullets are the same. A small handgun fires a much slower and lighter bullet than a military rifle, and a rifle produces far more energy on impact. That's why bulletproof glass comes in different protection levels. The thinnest type is designed to stop handgun bullets. You'll often find it in banks, jewelry stores, and security booths. The next level is much thicker, built to stop high-powered rifles used in embassies, government buildings, and armored vehicles. Then comes the highest level, designed to resist armor-piercing ammunition. These windows can be several centimeters thick, some weigh hundreds of kilograms for a single panel. The stronger the protection, the thicker and heavier the glass becomes. But here's something interesting. Even the strongest, bulletproof glass has limits. If enough bullets strike the exact same spot again and again, the layers will eventually lose their strength. That's why engineers don't say bulletproof. They often prefer another term, bullet-resistant, because no material is truly indestructible. The goal isn't to survive forever. The goal is to protect people long enough to escape or for help to arrive, and in most situations, those few seconds can mean the difference between life and death. Most people think bulletproof glass exists only in banks or military vehicles, but the truth is far more surprising. You probably pass by bulletproof glass more often than you realize. Walk into a bank, the transparent window protecting the cashier is usually bullet-resistant. Visit a jewelry store, the display cases holding millions of dollars worth of diamonds may also use bullet-resistant glass. At airports, security checkpoints, and control towers often rely on the same technology. Government buildings use it to protect important offices. Embassies install it to defend against armed attacks. Even many police stations have bullet-resistant windows at public counters. But perhaps the most famous example is the vehicle of a president or head of state. These armored limousines use extremely thick, multi-layer, bullet-resistant glass strong enough withstand repeated gunfire while allowing passengers to see outside clearly. Some military vehicles go even further, using transparent armor that protects against powerful rifles and battlefield threats. Even certain aircraft and helicopters use special bullet-resistant windows to protect pilots during dangerous missions. Everywhere human lives need extra protection, engineers turn to the same solution: not magic, not ordinary glass, but layer upon layer of brilliant engineering, quietly protecting people every single day. So, is bulletproof glass unbreakable? Not at all. In fact, engineers never claim that it is impossible to break. Every material has a limit, even bulletproof glass. The real question isn't whether it can break, it's how much energy it can absorb before it fails. Every time a bullet hits the glass, some of its energy is absorbed. The outer layer cracks the plastic, stretches the bullet, slows down, but after several impacts, the protective layers begin to weaken. If multiple bullets strike exactly the same spot again and again, eventually the material may fail. That's why engineers perform extremely demanding tests. Real bullets are fired at different distances, different angles, different speeds. Again and again, every shot is carefully measured. How deep did the bullet go? Did any fragments pass through? Did the glass remain intact? Only after passing strict international standards can the glass be certified for real-world use. Some tests even simulate years of sunlight, heat, rain, freezing temperatures, and constant vibration, because the glass must remain reliable, not just today, but for many years. This is why modern bullet-resistant glass is trusted in banks, military vehicles, government buildings, and aircraft around the world. It isn't unbreakable, it's carefully engineered to protect lives when every second matters most. So how does bulletproof glass stop bullets? The answer isn't one special material, it's multiple layers working together. Hard glass slows the bullet, strong plastic absorbs the remaining energy. Each layer takes away a little more speed, a little more force, until finally the bullet stops. The glass may crack, but the people behind it remain safe. That's the true goal, not to keep the glass perfect, but to save human lives every single day. This incredible technology protects police officers, security guards, government leaders, bank employees, pilots, soldiers, and millions of ordinary people around the world. Most people walk past bullet-resistant glass without ever realizing it, because the greatest engineering inventions often work silently without drawing attention. The next time you see a clear glass window inside a bank, an armored vehicle, or secure building, remember this: you're not looking at ordinary glass, you're looking at one of the smartest engineering innovations ever created, a material designed not to be unbreakable but to absorb enough energy to protect a human life, and sometimes that single invention makes all the difference. If you enjoyed this documentary, don't forget to like, share, and subscribe to *RailForge***, because here we explore the incredible engineering behind mega structures, modern technology, and the inventions that make our world safer. Thanks for watching, and we'll see you in the next documentary.